welcome back. Part 2 of the Silver Bullet P-Pump swap. Made a lot of headway, got a long way to go, got a lot to do. Stay tuned, and I hope you enjoy what you're seeing. This is pretty much everything you need to do in order to do a P-Pump swap on a 24 valve. Let's see here. I'm going to go through all the little pieces, parts that I've got sitting here, so y'all kind of have an idea of what I got. Got the old harmonic balancer here. You notice all the rubber is intact on this one, so really cross my fingers. I think it should be fine. It looks identical to the other one, other than it's got the notch here for the pickup that the 12 valve uses, which I don't really care about that on the 24 valve. Doesn't really matter. Cam retainer. I'll probably just swap this with the cam so you can keep it organized with my cam. Not that it has to. There's no real reason to, other than just my OCD. That's pretty much it. This is the lift pump, low pressure side. Something for you guys who are maybe new to 12 valves, keep in mind, there is 2 versions of this guy, and this is the updated version. You'll notice this part of it is a big old beefy thing, and the older version, this portion is half this size. And really the only reason they changed this was, this is how you prime the system. You sit here and push in and out on that guy, and it pumps fuel everywhere, right? The older ones, it took a bazillion pumps of this thing to get the stupid thing to prime. So one of the nice things Cummins did for us all, our own peace of mind and sanity, is they went ahead and made this a little bigger. It was a great improvement. Absolutely great improvement. This guy is critical. This is the bracket that supports the tail side of the P-pump. You got to have this. The P-pump's too big for these motors in the first place. The way they built in my opinion, the timing cover should have been twice as thick and heavy duty as it is, and have a tail shaft support on there. That's why, it's my theory as to why 12 valves especially have a lot of oil leak issues. There's just so much weight hanging off of that piece of aluminum back there, and it just flexes things too much. So this guy's critical. Without it, you will have a lot of problems and some critical failures in your build at some point. This is the automatic shutdown solenoid. So this is the little guy that shuts your fuel on and off when you turn the key. This is also the little guy that, if your battery is dead, or it's going to die because your alternator died and you're in the middle of a road trip, if you wire this little doodad up like this, the truck will stay running. You need 0 electricity to run this motor as long as that guy is held in this position. So however you get around to doing that, piece of wire, coat hanger, the sleeve off your shirt, whatever you come up with on the side of the road, it's a great little field expedient way to keep trucking. This is critical as well. This is the oil feed. The VP44 uses a single 90 degree that goes down to the vacuum pump. This gives me the T that I need to then pump oil up to the P pump, and the factory line for that. New gasket for the vacuum pump. Not that I necessarily needed it, but it's been a little molested over the years, so I figured it was better to go ahead and buy a new one. New front main. This is critical. You cannot take this stuff apart and not replace this. These little guys, I'm going to leave it in the box, and I'm going to take it out and show it to you guys, because oil, this thing is like the most oil sensitive critter you will ever see in your life. There's no oil that touches this thing in any way, shape, or form. If you can pull that off, these work great and they'll never leak. But they get one little driblet of oil on them of any kind, and this thing will leak like a sieve. It's some sort of funky, proprietary to Cummins. That's the only place I've ever seen it. Sealing material, and it is absolutely a dry seal. So there's that guy, and the reason you have to change that is you can't take the you can't take the cover off or any of that stuff without getting oil on that seal. And it's also really funny material too. Like I don't think you could put it back on. There's a little disc that goes inside of it. It's kind of cone shaped, and it goes over the snout of the crank. And as you push the cover on, it kind of spreads that seal out a little bit and helps it go on. So yeah, this is so. Next big thing is the gear case portion. I can't remember what the specific name for this bad boy is, but this is one of the most expensive pieces and hardest to source of this whole project. And really the main thing here is you need these 4 bolts right here in the right place, and this cut out properly for the P-pump. The rest of this thing, all the rest of the stuff, same gasket, same parts and pieces. This changes. And I pulled all this apart and did a head gasket on this motor a long time ago, and did a cam. A, it was cool, and because that's all that really matters. And B, it was doing some weird things with smoke, and we couldn't quite figure it out. And the power was a little wonky on the truck. And so I was like, you know what, screw it, I'm going to put a cam in this thing. And we pulled it out, and it had 300,000 miles on the factory cam, and the lobes were starting to flatten. So that was the problem. We put the new cam in, the smoke problem went away, the weird power funky spot went away, and everything was just great. But on 24 valves, they say it makes a big difference. So I'm looking forward to that. We'll see how this thing runs. Here's the outer timing cover. Just notice there's a scuff here, and that's right where the cam gear rides. So this new cam was drilled and set up for a cam gear retainer, and that must be what's touching here, so it's a little thicker. Interesting. It didn't seem to have been hurting anything, but yeah, I'll have to pay attention to that when I go back together with this. This is the next uber ultra important piece of this whole process. The injector lines. Look at that wonderfulness. This is one of the only parts I've purchased for this job so far, besides gaskets. Bought these a long time ago. I can tell, I can't even remember who I bought them from, what the brand is. And just right off the bat, I can see I'm going to have to do some bending here. These should this should come out to a nice line. I don't know if you guys can see that very well or not, but they should be even because they screw down evenly, right? So I'm going to have to do some tweaking here. The 99.9% solution, not perfect. And I would agree, like this little keeper, it's just not as nice as the factory ones. It's a little crooked, not quite as perfect. I might even try to steal some factory original pieces and swap them over onto this one, because the factory ones are just really nice. But these are really nice stainless. It's pretty awesome. I'm happy. Haven't even pulled these out of the box since 6 or 7 years ago when I bought them. Well, probably not that long ago, because I don't think I've had the truck that long. I think the one that all this came out of was still running then. Win on my part, didn't even know it, but I had bought one of the cool little spacers, so that was pretty awesome. So I don't have to go machine this in the mill or try to figure out how to do it on a lathe, because it would have been a fun lathe project though. I'm sure there's a way. You can do about anything on a lathe if you're patient enough. So that's really cool. That just saved me a lot of work. These are the extra long bolts that came with it. I'm a little bummed they're Allens. I kind of like the factory 10 mil stuff, because you don't really have to change anything. You just, tear 3/4 of these motors apart with a stupid 10 millimeter socket. And no, I haven't lost all mine. Pump gear, which we desperately need in order to do this swap. This is a different pump gear than comes on the 24 valves, so we need this bad boy. So glad to have this. We'll save the best for last. There we've got camshaft goodness. Can't wait to put this in, see how this motor runs on this thing. I think this motor is suffering from the same sort of issues that the motor that I put this one in had too, because this one, and it's all original. I think maybe the injection pump got swapped out at one point in time, but probably in like the 100,000 mile mark, and I've put 250,000 miles on this truck, and honestly, it's still practically just about mint condition. It's a pretty awesome truck. I love it. Gaskets, you know, inner timing cover. And we've got the outer timing cover. I do plan on taking the tappet cover off, so anytime you're in, change this thing out because it's a bitch to get to. You gotta take the pump off to get to it, and they all leak. Every last one of them. And then we've got valve cover gaskets here for the 24 valve. I don't know that I really needed it, but it's not that expensive. And I'd rather have it than need to make the 2-hour round trip to go to Rocky Mountain Commons and back. Don't mind that, that was the gaskets falling off the other bench. Return line, harvested off the other motor. Pressure line, again harvested off the other motor. I am probably going to swap this over to run AN fittings coming out from that end. I really hate this stuff. It just sucks. Correction, return line. Just because we're going to put a water pump in this thing. Mostly because there's just a little bit of slop in there, and they're super easy. It's just 2 little bolts and an O-ring. It's pretty awesome. And better to do it now than put all this together, do all this work, and then be like, man, I gotta take this stupid truck apart and put a stupid water pump in it because it just failed the water pump. This is the part I gotta get creative with here. This is the 24 valve throttle and the TPS. So it's got this big honking aluminum piece that it uses to mount itself. Don't ask me why Cummins did this, like, or Dodge, whoever built this, like, whatever engineer, good God. I mean, it literally is a remote-mounted throttle position sensor. See, there's a little sensor right there. That's the only thing this does. All of this stuff, all of that, just to do that. Just for that. It's crazy. I don't know what the hell it is. This thing weighs like 10 pounds, too. It ain't light. And the bolts, look at the size of that bolt to hold that thing up. It needs that just to hold all this weight. That's ridiculous. I don't know, whatever. I don't know why Cummins did that. I think that is everything but the best part. The P-pump. Bulletproof and runs forever. Runs no matter what happens in the world. This one is all stock. There is nothing that's ever been done to it. You can see the factory seal here is on that. Same with on the back cover here. We have been into this pump up on the top side and messed with the fueling just a little bit, and it was a little bit advanced on the other motor as well. And I'll run this one advanced too. Like there's just no reason not to advance them. They just run so much better. That's pretty much all the parts and pieces that I harvested off the other motor. Kind of remains to be seen just what all else I'm going to need or what I'm going to have to manufacture myself to make this all work. Obviously, we know that I've got to manufacture something here. What I end up doing, I'm really trying to avoid buying parts, so if I can avoid that, I will. This is the little, you can't really see it there very well, but this is the timing pin for setting the motor on top dead center. So I'm pretty sure that's where the cam sensor goes. Honestly, never changed one on a 24 valve, so this will be a first if I run into that. If not, then I don't think I even have to deal with that, which is awesome. And I just have to deal with this. And it's kind of ironic because this is the whole reason I'm doing this in the first place, is so it just needs to get changed and make go away. But the computer's like $1,500. All this stuff, well, I already bought that a long time ago and have long since paid for it, and hopefully it runs a lot better. I'm looking forward to it. So. All right, here's where we're at. We've got everything tore down. Got the cam out. I've got all the parts sitting here. It's pretty much everything. You can tell which one came out of the motor, the good motor, and which one came out of the bad motor. I'll let you guess down below real quick. You know, is it the really grimy one? Is it the really nice one? What I'm working on right now is this little bad boy right here. Cam sensor goes in right here. and reads cam timing by looking at this little dot as it comes around, which is in the same place as that little dot on the 12 valve. What this little dot does on the 12 valve is it uses this little doohickey right here, and it comes around, and that little doohickey sits down in there and is how you set these motors to top dead center and time everything. Problem with 24 valve is you don't have that luxury on a 24 valve. You have a cam sensor. Doesn't lock anything. Kind of sucks. So what I've got to do, I've got to swap this gear to this camshaft because I want my tack to work, and I can't make a tack work without this little guy. So how do I do that? Well, this is what the 12 valve comes with. Sorry for reaching across. And that holds that like that. And unfortunately, that doesn't work so well. So I got to build something that mimics, that was the fan I just kicked over, this big embossing back here. So that's what I'm working on this morning. I'm going to turn one out on the lathe and kind of show you guys how I do that. While I'm at it, if you also notice, I don't know if you can really tell or not, but that is a different diameter, meaning hot dog in the hallway. So I'm going to make another one of these that is the same size as this, so that I can take this guy out, drop that guy in place, and time my motor. So that's going to be cool when that's done. Alright, so here we are at the lathe. And I'm starting to get set up and doing a little bit of maintenance on this little girl. It's my Atlas II / Craftsman. It's a 10-inch lathe. I don't know, it's, I guess, still in the same category as your quote-unquote mini hobbyist lathes, only it's pretty old and wore out though. You know, the table has got a heck of a lot of chipping, and I don't know, we had some like freak weird weather last year, and I must have had this thing too clean, and like it's got a little surface rust on it. The three jaw chuck, which looked brand new when I got this thing, is all rusty now. I don't know. It does what I need it to do, which is mostly building bushings and low accuracy projects like this little guy. So that I'm working on now. Anyway, we're going to be using this block of aluminum right here to build what we need. And oh, I left the other piece down there. Dang it. Well, this is what I'm going to make that all work with. Should be kind of interesting. And I'm going to show you how I'm doing as I go along here. I want to show you guys the beginning of this. Like, I don't need all this ginormous hunk of metal. It would cause issues in the lathe trying to turn it and get it all set up the way I need it. So I'm going to make it a little shorter. I'm going to do this anyway. Might as well do it now and get this step out of the way. I'm going to show you kind of my process for how I cut something like this on the bandsaw and keep it square. So I've etched out some lines. How well you guys can see that. So I've etched out my lines here all the way around, and they're pretty square. I'm not too worried about them being perfectly square. And I'm not too worried about if I can see the line perfectly. Like, this is just a rough cut, doesn't matter. I'm going to face this on the lathe anyway, so it doesn't really matter. As long as my distance between here and here is long enough for my piece and for me to grab a hold of it. It's not necessarily a required piece of this, or required step, but I feel a little more comfortable doing it that way. I'm not a machinist by it, so it just makes it a little easier for me. And then what I'm going to do, and I've already started here, is put it up on the bandsaw here and start cutting. And you can see I've already kind of messed it up a little bit. And this is why I do it this way. Because if you just throw this thing on the bandsaw and start cutting, as you can see, like I got a nice square cut here, and I got a crooked cut over here. Like, the bandsaw is going to cut crooked. That's what they do. But they do a lot better if you give them a guide. So now this has got a guide here. I'm working on making my guide here. And I'm just going to slowly work this thing around on the bandsaw until I've cut a pretty decent guide all the way around the whole way around this thing, and then I can just put this thing down flat. That gives the material then gives the blade a guide, and it's still going to walk a little bit because the blade can side cut some, but it's going to keep it a whole lot squarer than if you just let that thing pick its own direction and go. And normally I don't bother, but for as big a chunk of metal as I'm trying to go through here, I think it's a good idea. There you have it. That's the mill. And you can see while it's not perfect, if I did a demonstration the other direction, this thing would look kind of more like a triangle than a cube. Alright, so here's where we're at. Same block, cut off before. I faced this edge here, made this nice and flat and square. Note the amazingly smooth finish on that, like best I've ever done. Super awesome, thumbs up on that. Now what I'm working on is boring the center hole that the cam sensor goes in. You notice right now it don't fit. There's a reason behind that. What I also have to do is this thing's got to have mounting holes, right? So it's got to match the same way that the original 12 valve bracket for the alignment pin. So the idea I came up with to do this, because it doesn't have to be super accurate, but you know, I'd like these two holes here to be as close as I can. You know, this thing has to be oil tight, and also I have to put an O-ring groove on this surface as well. That's, you know, it's going to be pretty accurate. These holes not such a big deal, but I decided it's going to be a lot easier just to do this whole operation on the lathe. I can do all these holes and this center hole, everything right here on the lathe. But then the question became, well, how do I transfer these holes without doing a whole bunch of math, which I'm not good at math. So I tend to lean towards what's the most foolproof way I can do this. So what I came up with was a grand little idea. I'm going to take my alignment pin and I machine this hole out to where this alignment pin fits in there. I mean, I could probably go another thou out with this, but that's really not the end of the world if I do or don't. So, got this nice and stuck in there, and then I'm going to put this guy on here. Now this is all nice and aligned, and I can decide where I want to put it. I guess if I had really thought ahead, I could have offset this hole to where I could have reused one of these machined lines here and saved myself some grinding on the sander, but whatever. Then what I'm going to do is just some Sharpie, black Sharpie, cover all this up. You can use Dicam for this too, but I don't have brushable Dicam. All I have is spray can Dicam. So, and I don't want to get Dicam all over my lathe. So, the Sharpie method does work, albeit not quite as good. I do like Dicam better. So I'm going to put this on here, roughly right about there. And not normally the hammer I would use for something like this, but whatever. And I'm just going to transfer punch this. Of course, I goofed up. Huh. I knew I was going to mess this up. Why didn't you guys stop me? To ensure I don't goof this up. I'm trying to etch this pretty deep because this is going to be my guide for when I cut this thing to its final size as well. And the Sharpie is going to come off. Sharpie does not tend to like stay. What I really need is another transfer punch. There we go. 2 center punch marks. Yep, perfectly aligned. So now, finish boring out my hole to the correct size. And I goofed that up. Of course I messed that up. I was going to go straight up and down. Okay, I guess we're doing this on the drill press now. But my marks are here. Because now it's going to be easier on the drill press. What I was supposed to do was draw a centerline line here and put these 2 holes right on the center line, straight up and down this way. And then all I had to do was loosen these 2 jaws, slide this thing up and down based on where I wanted my holes. And voila, complete. Since I neglected to do that and I got, oh hey, look at, I'll just do this fancy way over here, I messed that plan up. Because now I would, in order to do that, I would have to loosen both of these and shift this whole assembly over. That's a pain in the butt. I can do that easier on my drill press. So I think, yep, that is that. We're going to move forward and keep making chips. It's pretty much done. Got the O-ring groove in it right there. Got the other side faced. This thing is, according to the dial indicator, is within 2 thou, which is pretty damn amazing. I must say so myself. It's definitely the closest I think I've ever managed to pull something like this off. So here we are, drill press time. Since I screwed up my plan to drill these on the lathe, this is it. So I've got this pretty awesome tool attachment for it. And I know there's a specific name for it that I'm completely forgetting right now. But regardless, I have it and it allows me to move this thing on the X and Y axis without moving my work. So it's kind of like a mini mill setup, only you can't use these things as a mill because the chuck falls out, and look how spindly that quill is. I mean, it's all held up here by big, massive, heavy stuff, but you got all that metal down here that's unsupported, and this thing will just chatter to holy hell and break stuff, and the drill truck will fall out, and just all kinds of bad stuff happens. So we're going to chuck this thing up and get this drilled. And then I'm going to trace some marks on it, because I think my marks are a little off, and make it actually look like it's supposed to look. And I still got to drill the hole for the sensor, but I don't want that to be a through hole, so I'm waiting till I have these 2 drilled, and I can line the sensor up the way, I don't know, the way I want to line it up, I guess. I don't think it's not a big deal regardless, but anyway, that's where we're at. Let's get it done. Almost there. Alright, to the last step, aside from cutting my nice little shape into this thing, is drilling the hole for the sensor. I've decided I'm going to stick it in a little bit of an angle. I'm also going to go in and oversize these holes because they are on the other version of this, and I believe that is so you can actually align this tool. Something I never thought about until just now when I was thinking through this whole project through, is this thing, his little holder has to be aligned so that this thing will actually work, which is why I think we could never get this to work on the Blue Bomber when we had it all apart. Tell you that story another day. So in order to be able to oversize these holes, and especially since I don't have a mill to do like some of the other manufacturers who actually manufacture these things do, where they recess this hole down a little bit to give room for this 6mm bolt that holds this little guy down like that. In order for me to do all this, I gotta offset it a little bit, and I'll probably have to grind that plastic down a little bit too. We'll just see how it all goes together, but that's kind of where I'm going. What I wanted to show you, so this is a little 6x10. Here's my tap for it. When I read my tap chart, I want a good tight fit. So when I find the 6x1 and it says I need a 5mm drill bit, well, I don't have a metric drill set. So what I've decided I'm going to do, and I think it'll work just fine, got my little digital dial indicator here and set it to metric, and then went over to my drill index and I found one that is really darn close. So it's actually kind of a cross between the 60 and 75% fit. Yes, the 60% wants a 5.2, and the 75% fit wants a 5.0. So I think it'll. If I decide it's a little too tight, I could even jump it up one more step, and it'll probably all work out really well. But I just don't want this bolt hole to get crummy over time and be loose up front with this too, because I don't even know what type of aluminum this is. This could be a soft aluminum that doesn't want to hold the thread either. So that's why I'm doing what I'm doing. I'm gonna go chuck this back in the drill press, put a hole in there. Already got it center punched where I want it, and bolt this all together. I've already test fit the depth, because this thing has to have a certain depth that it sticks out here. I've already tested all that, and that I think I hit it well within margin of error, and it's definitely not too deep. So that's pretty darn awesome. And yeah, I think once I get this hole drilled, then I got the fun job of, since I don't have a mill, I'll use the bandsaw to cut the majority of this down, and then I'll be over at the grinding wheel for a while, grinding this all down to make this look nice. But it'll look just about like that marking when I'm done. And then it's off to making the oversized one of these. That's the next fun step in this whole process. And that's the other reason why I want this hole to fit really good and not be a pre-worn out thread, because if I'm gonna take this little guy in and out so that I can use this little guy, I want those threads to have as long a lifespan as possible. So yeah, it's time to build that. Hopefully that'll go faster than this, because it's like 3 o'clock in the afternoon and I started this at 8:39 this morning and I'm still going on it. It's going to be all day of just machining, and I haven't done anything. I wanted to have the cam in this today. It's still sitting there right where I left it. Yay. Alright, real quick, I wanted to show you guys a shop hack tip for you. Something that works really, really good for aligning taps. Use your drill press. They have a fancy tool for this. I actually ordered one, but I don't have it yet. Use drill press and your deburring tool. And, I just drilled this hole, so everything's perfectly aligned. And just use your deburring tool, put a little bit of downward pressure on that, and just kind of hold it with your hand and turn the tap. There's a, this spot right here is perfectly machined. It's part of the machining process to make this piece. So this is in perfect alignment right there. Dead nuts straight with the quill of the drill press, and therefore you get a perfectly straight tapped hole. And yeah, it's amazing. No messing with it. Alright, there it is, all roughed in. Got my hole tapped. If you notice, I did not cut all the way up to the die cam lines. I had to redo my die cam. Didn't do a very good job of the redo either. But the reason you do that is this is the rough cut. We're going to do the actual final cut on this guy. And by doing that, this gives me a reference that I can put this thing up against here. And now I will sand it down in a controlled manner right down to that line. And by the time I'm done with this, it's going to look almost machined. So Anyway, yeah, that was about 20 minutes of bandsawing to get to this point. Now I got probably at least 30 minutes of disc grinding to get this thing all finished up, but we're almost there. When I'm doing this, just leave it flat on the table here and just push it in up here to the edge. And it'll cut faster out here towards the outer edge. Down in here, the speed's a lot slower. It's not rotating as fast. You won't move as much metal as quickly. We'll just kind of gently rub it down. Watching for that blue outer die-cam line to disappear. And we know we're getting really close. So, get into it. Alright, here we are. All done. Completed project. O-ring groove. I'm waiting to drill these other 2 holes. I know I said I was going to. Kind of decided they're a good fit right now, and I'm going to hold off and see just how the alignment is. You know, if I don't need to mess with it, I'm not going to. But that's it. Goes just right here. And it looks like the holes line up pretty darn good. Might be some of the best holes I've ever done. You won't be able to see it in the camera, so I'm not even going to try to show you. But that goes on there. I have a cam sensor. Alright, here it is, finished product. Got my adapter all done. I think it looks pretty good. Got my hole drilled. Bolt threads in really nice and clean. Doesn't quite go all the way to the bottom, but it doesn't matter because it more than squishes that. Really, this thing came out perfect. I haven't been able to test the bolt holes because I don't have a long enough bolt yet, but just visually looking at it, I think these bolt holes line up just fine. The only thing that didn't quite come out as well as I would have liked is there's a bit of a taper on here. And I mean, I could fix that. I've got some hones and stuff. I could come in here and take a little bit of material out of that and square this thing up a bit. But I don't think it's worth it. And I just built all this stuff and it all works. So if I did that, it may not work after I'm done. So really it just means that this O-ring's got a good, nice, tight seal to it. I think this O-ring is going to have a really good seal to it too. So like this thing really shouldn't leak, which would be pretty awesome because I really hate leaks. And then I got my alignment tool all made. Pretty snazzy. I didn't actually have a solid bar, so I had to get really creative and drilled that out to just a known size. And then I found another piece of aluminum and machined that down to a pressed fit and pounded it down in there and then machined this as one single body. I was a little worried that I was going to drill or cut all the way through this because I didn't know how thick this was here. So I don't know, visually looks like I did okay. I don't think it's going to break. Might be a little on the thin side though. Looks like it might be around 1/8. Yeah, whatever. But my fit here is like, God, I couldn't, and this is another reason I wouldn't hone on that because the fit is just perfect. I mean, it goes in here, but it has like just a little bit of, I don't know if you can see that in the camera or not. And that's really only there because of the stupid taper. I mean, if it wasn't for the taper, I could have done even better than this, but that's okay because it's still good. And it's got plenty of throw all the way through. I think it's going to work. So that's that in a nutshell. If I had to do this over again, if I had the money, I would absolutely buy this guy. Making this, I mean, I've got like 10 hours into these 2 pieces today. I mean, this is all I've done today, and it's after 6, so yeah, I've got like 12 hours into this project at this point. Now I guess 10. Yeah, right at 10. Just to make these 2 parts. It's pretty crazy, but you know, this aluminum I got from the steel store that I go to. You know, they have a scrap aluminum bin in the back, and I just bought a whole bunch of stuff one day when I was there. It was like, they have like a $20 minimum, and you walk out with more than you can carry in an arm load. So that's where this came from. So we'll say this cost me like 2 cents. This was some leftover pieces from snowmobiles. So, I mean, snowmobiles aren't cheap to buy, but I buy old ones and refurbish them. So we'll say this little guy probably cost me $100 right here because of the snowmobile part. But it was in the scrap bin, so whatever. And that came with it. The O-ring, just have an O-ring kit. This is the factory bolt that attaches that from the factory. So, yeah, I mean, all told, I've got, a few pennies into this little project. And a lot of time. I add up the time, 8 hours, that my time is worth quite a bit of money. So that's, it probably, with time and labor involved, or added in, I mean, I paid more for this than it would have cost me to just go buy the thing. But aftermarket doesn't give you that. So, yeah, no. The only reason I did this is I just need to save money on this project wherever I can. So, a couple bucks in a day makes a little more sense. So that is that, and that's a wrap for this project.